Welcome to lecture number 38. This is lecture number 38, and before this we have solved a problem in lecture number 36 and 37. We have solved the same problem using two different techniques. In lecture number 36 we solved this circuit to find V out using Norton's theorem, and in lecture number 37 we use the same circuit but a different technique, nodal analysis, and we reach the same answer. Right, in this lecture number 38, we will be solving for the same circuit, this circuit, using loop analysis. Right, in order to solve this circuit using loop analysis, we'll assume two loops, one loop and the second loop, and we'll assume two different currents for the loops. Current for this loop we'll assume it to be I1, and for this loop we'll assume the current to be I sub 2. Right, so the equation for the first loop would be, starting from here, it's the current, our assumed current is entering from the negative side. We'll write it as voltage rise, and we'll write it negative. We have already studied that we assume all voltage rises to be negative and all voltage drops to be positive. And then through this 1 ohm resistor we have only one current I1 flowing, so the voltage drop would be I1 times 1. Plus through this J1 we have two currents, I1 going downwards, I2 going upwards, so the net current would be I1 minus I2 times J1. Right, J1 I1 minus J1 I2. Now we can collect the coefficients of I1 and I2 together, and we reach to this equation number 1. That is for loop number 1. For loop number 2 we have through this J1 two currents flowing, I2 minus I1, and since we are in loop number 2, therefore we'll write I2 positive and I1 negative, and then minus J1. This minus is there because it's a capacitive reactance, minus J1 I2, plus the current flowing through this 1 ohm resistor is I2. So the two terms cancel here, J1 I2 minus J1 I2, and we are left with this expression, I2 is equal to J1 I2. And this is our equation number 2. So now we can put the value of I2 here in equation number 1. Right, so once we put I2 here, this equation number 1 will have only one variable, that is I1. We solve for this and we'll reach to a value I1 is 10 over 2 plus J1. Right, we have to find V out, and V out is I2 times this CL 1 ohm, so we have to find I2. So putting the value of I1, where will we put it to find the value of I2 current? What is the simplest possible way to find I2? This is, put this I1 here in this equation. So now we'll have I2 is equal to J1 times 10 over 2 plus J1. So we have put the value of I1 here in this equation. And once we have computed I2, the rest of the thing is very simple, because now the output voltage V out is, according to Ohm's law, is the current flowing through this 1 ohm resistor times 1 ohm. So this is the current flowing, J10 over 2 plus J1 times 1, so it remains the same, J10 over 2 plus J1. And once we convert these numbers into polar form, we reach the same answer where we reached in case of Norton's theorem. And when we solved this circuit using Norton's theorem in lecture number 36, and using nodal analysis in lecture number 37. So to conclude lecture 36, 37 and 38, we have solved the same problem using 3 different techniques and we reached to the same answer. In our next lectures, we will keep on studying AC circuit analysis. Thank you.